Okay, so this is question 8.1, and we need to solve this for test 3, part 1. So for this question, we're looking to find the total momentum before the collision. And we want to find both the magnitude and the direction of this momentum. So first, I'm going to draw the sketch that I used to solve this problem. So we have these vectors, and we have this as px, or the momentum in the x direction, and we have this as py, or the momentum in the y direction. And this is the magnitude of the momentum, so delta p. Absolute value of p. So this is the sketch that we use, and we see this angle here as theta. So in order to solve this problem, we need to see the equations for the momentum in the x direction. And given the values in the question, we can see that it's 2.0 times 10 to the 4th kilograms times meters per second. So this is the equation for momentum in the x direction. Now we can do py, or the momentum in the y direction, which is 1.5 times 10 to the 4th kilograms times meters per second. Now that we have the equation for the momentum in the y direction, we can find the magnitude of the momentum. So this will be square root 2.0 times 10 for kilograms, need it to be longer, times meters per second, a little longer, plus 1.5 times 10 to the 4th kilograms, it's very long, times meters per second. Okay, so basically what we did here is we combined the two equations that were up here that we solved earlier. So this is the magnitude of the momentum. So when we solve this, we're going to see that the magnitude of the momentum is 2.5 times 10 to the 4th kilograms, times meters per second. So this is the magnitude of the momentum. And now we also need to find, we didn't just need to find the magnitude, we also need to find the direction. So now let's go to find the direction of this momentum. So to find the direction, what we need to do is take our angle theta over here, and we know that that's tangent theta. So tan theta is equal to the momentum in the y direction over the momentum in the x direction. So now this is pretty easy to solve. We just need to plug in our values. So we have 1.5 times 10 to the 4th kilograms times meters per second. And we divide this by the momentum in the x direction, which is 2.0 times 10 to the 4th kilograms times meters per second. Now we solve this, and the answer would be theta is equal to 36.9 degrees. So now this is the direction of the momentum.